If you want to understand how to write code, it helps to think of a computer as a highly capable, literal-minded helper. It has incredible speed, but it will do absolutely nothing without an exact instruction. Let's call our little helper Pi. To tell Pi what to do, we need a shared language, and in our case, it's Python. The very first command you teach Pi is called print. It is the simplest directive in Python, and we use it to make the computer output text directly to your screen. Python requires a very specific structure to understand you. When you write the print command, you have to follow it immediately with a pair of parentheses and place your message inside them. So if we write the word print, followed by parentheses holding the words "Hello World" in quotation marks, Pi reads the instruction and displays that exact text on the screen. Pi can even learn new tricks using extra instruction manuals called libraries. By giving Pi access to a manual called Colorama, we can tell it to change the color of the text, turning a standard white sentence into bright red, blue, or green. Making the computer speak is a great first step, but to do complex tasks, Pi needs a memory. It needs a way to hold on to information, which brings us to the concept of variables. In Python, variables are simply reserved areas of memory. You can think of them as physical cardboard boxes sitting on Pi's desk, each with a custom label written on the side. Unlike some other languages, Python doesn't require complex commands to build these boxes. A variable is created the moment Pi assigns a value to it. You write your label, like name, and drop your data inside. The boxes are incredibly flexible. Pi completely swats the data inside, like replacing a name with the number 10. Keep in mind, these variables are just storage containers. Pi won't show you what's inside the box until you explicitly use the print command to reveal it. Because these boxes can hold and update information on the fly, you can write a single set of instructions that handles entirely different data depending on what is stored inside. Now we need a way to fill those variables with information from the outside world. We do this using the input function. When Pi reads an input command, it pauses the entire program and waits for the user to type a response. Once the user hits enter, Pi grabs that information and tucks it safely into a variable box. To ensure the user knows what to type, you should always place a helpful text prompt inside the input parentheses, like "What is your name?" Combining these input prompts with variables allows your code to respond to new information in real time, creating a back-and-forth conversation between the user and the computer. Now, imagine you want Python to say "hello," followed by whatever name is currently stored inside your variable box. To blend your own text with the data inside a box, we use something called a formatted string. To set this up, place an F before the quotes and wrap the variable in curly braces. Python grabs the value and slots it into the sentence. Need human notes? Lines starting with a hashtag are comments, completely ignored by Python while working. To keep instructions organized, Python relies on visual spacing. Instead of using complex symbols to group blocks of code together, Python uses a standard indentation of exactly 4 spaces. These tools, the formatted strings, comments, and specific spacing, keep the communication clear for both the computer executing the code and the humans reading it later. Stacking commands creates a complete program: a human-readable comment, an input prompt, a variable box, and a formatted string. Python reads top to bottom. He ignores the comment, asks for the name, stores it, and uses that memory to say a personalized hello. By mastering these fundamental building blocks, you've learned the essential language required to start instructing your own digital robot.